So when we think of inverse functions, we can think of like opposite functions. For example, add and subtract are inverse functions of each other. Times and divide would be inverse functions of each other. Squares and square roots, cubes and cube roots, logs and exponential functions are inverses of each other. But we can also think of inverses slightly differently, and we can think of them as switching the x and y, or switching the input and the output. So we can undo things by just reversing the direction of our inputs and outputs. So if I have my function flowchart here, okay, so I have my f of x, my output is y, my input is x. If I switch my input and output, basically all I'm going to do is change the direction or flow of my flowchart, my function flowchart. Instead of going this way through the function, I'll undo it by going this way. So we can think of inverses that way, but for us, it's much simpler to look at it as just switching x and y values, okay, switching input and output. So what we can do is when we're looking at the squared function here, we can look at this, graph this function. So this is going to be a parabola. So vertex is at -2, 1. Okay, so I'm just going to sketch this parabola in, graphing these coordinates. Okay, so our parabola is going to look like this. Okay, so what does this look like when I do an inverse? Or essentially, I'm just going to make this x equals y plus 2 squared. So instead of y equals x plus 2 squared, we're just switching the x and y. That's essentially what an inverse is. And what I'm going to do is I'm going to take all my x's and just make them into y coordinates. I'm going to take all my y coordinates and make them into x coordinates. So 4, 1, 0, 1, 4. Okay, and then what happens to the graph then? Okay, so essentially inverses can be thought of inverse operations. We can think of inverses as going backwards to the flowchart, so switching our input and output, or switching x and y. We could also think of it as just switching x and y coordinates. Those are all consistent ideas. So what does it look like when we graph this? Okay, so if I graph this inverse, I'm going to have 0, -2, okay, 1, -1, okay, 4, 0, and I have 1, -3 here, and I'm going to have 4, -4. So I'm going to end up with this function here. Okay, so this is an inverse of that parabola. In fact, if we just kind of ignore the bottom half of this parabola, we end up with a square root function. And when we think of this inverse of a parabola, really it's the plus minus square root. Well, there's a plus square root, and here's the minus square root. So when we inverse a parabola where we solve for x squared, we always get plus minus. Well, this is why, because we get plus square root here and the minus square root here. And this is an inverse. It's basically taking the output, making it our input. Okay. Now, algebraically, if I just solve for this, I'm going to undo the squared here, and I end up with plus minus square root x equals y plus 2. So my equation then becomes 2 plus square root x, that would be the top half, and then y equals 2 minus square root x, which is the bottom half of that parabola. Okay, so I'll just highlight those so you can see the different parts here. So that represents the top half here, and this would represent the bottom half down here. Okay, so the idea of inverse of switching x and y, switching x and y variables, switching input and output, an inverse operation, squared, the inverse is square root. In fact, it's a true inverse because it gives me the plus minus square root. These are all consistent ideas. There's one other way we can look at inverse, and I'm just going to graph that inverse on this graph here. So it'll look like this. Okay, so we end up with this graph here like that, this graph here like that. Okay, so when we think of the inverse, we can also think of it as a reflection across this diagonal line. Okay, so a physical inverse has some symmetry to it. Okay, and we should think there's this mathematical symmetry we're just switching x and y input and output. So there's this physical symmetry, which is a reflection across this line. In fact, if we take a look at all the coordinates that are reflected across this line, 0, -2, -2, 0, they are reflections across this line. Okay, so when we switch x and y's, we get reflections across these lines, and the points that don't change, or the invariant points, are just going to be when x and y are the same. So when we switch x and y along this line, it doesn't change. So there it is. There's a mirror image of that original parabola. So again, the inverse can be thought of as an inverse operation. For example, squares to square root. For our purposes, it's probably easier just to think of inverse as switching x and y coordinates. Okay, and we get this mirror image. Inverse can be thought of switching input and output, switching x and y variables. And lastly, we can also think of inverse as actually switching x and y axes.